This section is 6.2 called Rational Exponents.
Is there any more brown cider?
Guys, I'm taping. Whenever you're dealing with a radical and you have it in, you see a radical in the equation, it is called radical form. Now we can put this in what's called rational exponent form, which looks like this. This here is the power, and this is the root. So when you rewrite it, you have the x, the power goes on top, and the root goes on bottom. So we have the square root of x can be written as x to the 1/2 power. They both mean the same. Let's try some problems. We have the square root of x to the 6th over the square root of x to the 3rd. We're going to rewrite them in rational exponent form, which is power over root, power over root. And when we kind of a review on the properties of exponents is that if when you have one exponent timesing that you have the same base and they're multiplying, then you're adding the exponents. Then if you have the same base, they're dividing, you're actually subtracting the exponents. Then if you have to a base raised to another power, that's when you multiply the exponents. That's kind of a little review of the things that you might need to know in order to simplifying these rational exponents. So since this is dividing, we're going to use this one where we're going to subtract our exponents, which gives us 3 over 2. So our answer is x to the exponent of 3 over 2. Here's another one. We have the square root of x to the 6th power over the cubed root of x to the 2nd power. We're going to rewrite those as exponential equation, or exponents. 6 over power over root, and then we have x power of 2 over the 3rd root. Since they're dividing, we're going to subtract. So we have x 6 over 2 minus 2 over 3. Of course, in order to subtract fractions, you have to have like denominators. This is times 3, and that's times 2. So we would have x to 4 over 6. This here, the fraction, we could take out a 2 from each one to get 7 over 3. This right here is our answer. Please leave it in an improper form, because some people might want to be tempted to make it 2 1/3, like a mixed number, and that's wrong. It would be a wrong thing to do. Leave it in improper form. Now we have another equation, or not equation, but another problem. X to the negative 2 times x to the negative 1 over x to the negative 2. Just like when we're reducing problems before, and we had like a x to the 4th over x to the 2nd. The powers, since the bases are the same, we could reduce them, which would leave 2 on the top. Because these powers are exactly the same, they're both negative, we could cancel those. And that leaves us with x to the negative 1. And sometimes the Hawk system tells us very clearly in the directions that do not leave exponents as negative. They want all positive powers. So you'd have to change that to be 1 over x. Both of those are correct, but Hawks sometimes is real picky about how it wants its answers. Another problem. Is x to the 1/2 power, and we're raising it to the power of 2/3. And we have power raised to a power, so those are going to multiply. So 1 times 2 is 2, and then 2 times 3 is 6. We can reduce that, and it becomes x to the 1/3 power. And that's our answer. Now let's mix it up and get some numbers in there. Over 5x to the y to the 4th. Since they're all multiplying, we can cancel if we wanted to. We don't have a number that we can pull out on that one, so the numbers would have to stay the same. But we have an x here and an x here. If we canceled those, they would kind of go away. It would be 1 on the top and the bottom. Now we have 2 y's on the top and 2 y's on the bottom, or 4 y's on the bottom. They're both positive, so we can cancel. It takes both of the y's on top, but leaves 2 on the bottom. So it leaves us with 3 over 5y squared. And that would be our answer. Now we have this problem. And anytime you have a negative exponent, we can get rid of the negative exponent by flipping the base. And in this case, all this right here is the base. Here's our choices. We can put our answer in, or our answer could be not a real number. Okay, so let's solve this. I like to get rid of my negative exponents, and to do that we have to flip the base. So we're going to take this and we're going to flip it. It's going to be over 27. And we can leave the negative in the top, or we could put it in the bottom. It really doesn't matter. But now we have 2 over 3. Or we could rewrite it as the cubed root of 125 over 27, and then we're going to square it. Power root. The top is the power, the bottom is the root. So negatives, when you have negatives inside odd roots, you're safe, because anytime, for instance, -5 times -5 times -5, that becomes 25 times -5, gives you a -125. So we're safe. It pulls out a -5 on the top. And the cubed root of 27 is 3. So we just took care of everything inside the parentheses. Now we're going to square it. -5 times -5 is 25. 3 times 3 is 9. And that is our answer. However, you're going to run into situations where, like I said, odd roots are safe with negative exponents inside the root. When you're not safe is when you have a negative inside an even root. This one's 2, so it's an even root. These are not safe, because no matter how you try, you can do 2 times 2 gives you 4. -2 times a -2 gives you a +4. Nowhere do we get a -4. So, sorry about that. Nowhere do we get a -4 for our answer. So this one would be a case where we have not a real answer. Okay? Even roots, remember, those are the ones that are not safe. If you have a negative inside, you're not going to have there will be no real answer for it. Now let's do this one. We have 7x squared times 6x to the negative third times x to the negative 2. We're going to use some of those properties that I showed you earlier, where we have the same base here, and we have a 7 times 6. So let's do the 7 times 6 first. Gives us 42. But now we have the same base, and they're multiplying, so we know that when they're multiplying, we just add the exponents. So 2 minus 3 is negative 1. Subtract 2 more from negative 1 gives you negative 3. So you get x to the negative 3 power. This negative 3 right here is rational. So your answer is this, and if Hawk said what you come up with an answer of this and Hawk says it wants all positive exponents, that's when you need to move this x to the bottom like this. The 42 stays on top, but the x has to go to the bottom to get rid of that negative exponent. That is another answer that you can use as well. Let's try this one. We have 64 to the 1/2 power. We're not used to seeing them this way. We could rewrite it if you wanted to look like this. What is the square root of 64? Because 1 is the power, 2 is the root. So it's the square root. The square root of 64 is 8. Now we're going to look at the cubed root of x to the 6th power times the cubed root of x to the 2nd power. Rewriting those in exponential or rational exponents, we get x 6 over 3 times x power over root. Since it's the same base, we know we can add, and we have like denominators, so we can just add the tops. So we get 6 plus 2 is 8 over 3. And we can't reduce that, so our answer is x to the power of 8 over 3. Power over root. Again, leave it in irrational form. We don't want to do mixed numbers. This looks a little bit different. 8 over 27. We're going to raise it to the 2/3 power. Now, we don't have a negative power here, so we don't have to flip the base. So we can basically take, this is the power, this is the root. So if we take the cubed root of 8 over 27 and then square our answer, what are we going to get? We know that 2 times 2 times 2 is 8. So the cubed root of 8 is 3, or the cubed root of 8 is 2. And then the cube root of 27 is 3. Then we don't forget to square it. So 2 times 2 is 4. 3 times 3 is 9. Our answer for this problem is 4 over 9. Now let's try one that's a little more complex. We have 8 x to the 2nd power, y to the negative 2 over x to the negative 3, y to the 3rd. And all of this is being raised to the 1/3 power. Now, we could take everything inside here and reduce it down and then apply the power. Or we can apply the power to everything and then reduce it down. I'm going to do the second part of that. I'm going to apply this negative through, or the power through. So we have, there's really 8 to the 1st power here. So our power times power gives us 8 to the 1/3. Then we have x to 2/3. And then y, negative 2 times 1 is negative 2 over 3. And then we have to do our bottom as well, the denominator. So we have a negative 3 times 1/3 gives us a negative 1. And y, 3 times 1/3 is 1. Now we want to try to reduce and simplify it. So we have, what is the cube root of 8? It is 2. Then we have x's here. And they're dividing, so we know we have to subtract them. 2 over 3 minus 1 and 3 over 3. We can, because we know we have to have like denominators. So this one here will be x to the negative 1/3. Then we have negative 2 over 3, and we're subtracting. Ooh, I think I goofed up. I did goof up because we have 2 over 3 and we're subtracting, but we have to subtract a negative 1. So that should made it positive. And in this case, it would have been 5 over 3 instead. All right. Now let's go back to this one. We have negative 2 over 3, and we're going to subtract 1, and we're going to rewrite 1 as 3 over 3. And this one here we have, since the denominators are alike, we have negative 2 minus 3 is negative 5 over 3. So we would have y is negative 5 over 3. And that kind of looks really confusing, so I'm going to rewrite that answer down here. We have 2x to the 5/3, y to the negative 5/3, which is our answer. Again, if Hawks, you end up with this answer and Hawks says positive exponents, then this y, since it has a negative exponent, needs to be rewritten as a fraction like this, so that there is no negative exponents. Both of these are correct answers. Okay, let's do one more just to make sure we've got it. Y 2 over 3, z 2 over 3, and all of this is going to be taken to the negative 1/3 power. Little complex. We're going to apply this exponent to each one of these, multiplying it through. So we get x times the negative 2, and that's timesing by negative 1/3. And we have y 2/3 power times negative 1/3. Then we have z 2/3 power times negative 1/3 power. So we get, for our answer, x, negative times negative is a positive, and this is over 1, and we're multiplying, so we get 2 over 3. Here we're multiplying as well. We've got 2 times the negative 1, which is negative 2, and 3 times 3 is 9. And then z, we've got 2 times the negative 1, which is negative 2, over 3 times 3 is 9. Here's our answer. Again, if we don't want negative exponents as our answer, we have to write it in this form. But then we have fractions and fractions. Both of those answers are correct. Now, let's see if you can remember what we said about what's safe and what's not safe. We have negative 49 to the negative 1/2. 1 is the power, 2 is the root. So basically we have, if we rewrite this, we have a negative 49 inside an even root. Which would be, because this is an even number, it won't pull out the negative. So we have not a real number. That's our answer. Okay. Let's try this one. Y to the fourth inside the cubed root. Then we have the square root of y squared. Writing them as rational expressions, we have y power over root 4 over 3. Then we have y power over root 2 over 2. This one here actually reduces to 1. So when we have the same base and they're dividing so we can subtract them, we actually get y 4 over 3 minus 1, which we can rewrite that as 3 over 3, which gives us y to the 1/3 power. And that's our answer. Now, there will be cases where you will see these and they kind of look really funny, where you have a fifth root inside a fourth root inside that, and then a squared root here with a y. And they want you to simplify that. All you have to do is remember that you can multiply all your roots, which 5 times 4 is 20, and 20 times 2 is 40. So our answer is y to the 40th root. And the exponent on this is 1, which you can write that as a rational expression by putting y 1 over 40. There you go. Let's do a couple more. Here we have 3 inside 5x, and we want to simplify that. Just like we had a power raised to another power, those multiply, these multiply. So we have 15 with x inside, and if you rewrite that as a rational expression, you get 1 over 15. And that's your answer. So let's try, this is one more. Times 8x negative 1 times 8 to the negative 2. Okay, we have bases here. Those are the same variable, and they're multiplying together. We have 2 times 8, which is 16. So we take care of those. Now let's take care of we have the same base, and anytime you have the same base that are multiplying together, you can take the exponents and add them together. So we have negative 1/2 plus a negative 1, which is the same as subtracting 1, plus a negative 2, which is the same as subtracting 2. And we need to make these all with the same base. So this becomes 2 over 2, and becomes 4 over 2. So we have negative 1 minus 2 is negative 3, minus 4 is negative 7 over 2. So our answer is negative 16 to the exponent of negative 7 over 2. And that's it on that one.